All right, Algebra 2. So, compositions in real life. This is definitely something that you would benefit from. And a lot of times when you start dealing with money, and business stuff, you will see a lot of this actually in the real world. So, for instance, you work 40 hours a week at a furniture store. Awesome, great. You receive $220 weekly salary plus a 3% commission on sales over $5,000. Assume that you'll sell enough this week to get the commission. Given the 0.03x and x minus 5,000, which of f of g and g of f represent your commission? All right, so let's think about this really quick. So, if I do on commission on sales over $5,000, I have to at least sell $5,000, right? Like I get $220 a week. Cool, awesome, great. But I'm trying to figure out the representing my commission, right? So I have to start with 5,000, right? And then I get 3% of the stuff over that. Okay, so let's try this really quick. If I take f of g and I plug it in, so I take f, and then now I'm going to insert that g of x, right? I'm going to put in that g of x, so that's 3 times x minus 5,000, right? Let's simplify that. And then we've got 5,000 times 3%, or 0.03. That's 150. Okay, so that would be f of g. So that's really kind of saying what does x represent? Well, let's think about it. What does x actually represent? That's my total sales, right? So this is saying take 3% and then subtract 150 from it, and that's going to be your commission. Okay, so let's try g of x. So if I take g of f, that's going to give me x minus 5,000. And then I'm going to put that 3% times x. 3% times x. Okay, and this is saying take your total commissions, multiply it by 3%, and then subtract 5,000 from it, right? Now, the one thing that we haven't looked at is, do you get 3% on the commission of that $5,000 sales, like the ones before? No, you don't, right? Like it only happens after that $5,000. Okay? So that f of g is actually going to be our function. Because if you take your total sales and then you subtract that 150 off of it, that's going to go into that 5,000 pot, right? Okay, like for instance, if I hit that 5,000 mark, like I just get $5,000, let's look at how much commission I'm going to make based off of the first function. Minus 150. 0. And that makes sense because I'm not going to make a commission until I go over $5,000, right? Okay, let's look at this second one. If I plugged in 5,000, what would I make? Well, I better not owe them for negative $4,850, right? Like this means that I would owe them that much money. Well, I don't want that to happen, right? So let's say I sell 5,500, right? So if I sell 5,500, let's plug it into that first equation. 5,500 minus 150. That means that I make $15 on selling $500 more than what was expected, right? Or that cutoff. Okay? So your answer is going to be this first one, okay? Looking at number 2. You make a purchase at a local hardware store, but what you've bought is too big to take home in your car. For a small fee, you arrange to have the hardware store deliver your purchase for you. You pay for your purchase, plus the sale tax, plus the fee. The taxes are 7.5% and the fee is 20. Write a function t of x for the total after taxes on the purchase amount x. write another f of x for the total, including the delivery fee on the purchase and the amount. Okay, so you're going to write a function for the total after taxes on the purchase amount x. Okay, so first step, we're writing t of x, which is the total. So when you go to the store, you're going to buy something, right? Okay, so it's going to be that cost plus the tax, plus if you have a fee delivery to your car, then you're going to add that on, right? Okay, but for right now, we're just going to do the purchase amount and the taxes. Okay, so you're going to buy the thing, like let's say that you buy a pack of gum. Okay, that's like $2, right? Plus the 7.5% sales tax, or 0.075 times x, because that's how much the cost is, right? Okay, and that's t of x. That's what they told us right here. Okay, and then it says write another function, f of x, including the delivery fee on the purchase amount x. Another function for the total, including the delivery fee. So you're going to have x plus that sales tax plus the $20 delivery fee. But this one only says to include the delivery fee in the total on the purchase amount. Sorry, $20. Cool. Okay. Now it says calculate and interpret f of t and t of f, which results in a lower cost to you. Okay, so let's calculate that, right? So this is number 2. So we're calculating f of t of x. Okay, so that's going to be x plus 20, and then I'm going to take this function, I'm actually going to plug it in. So I'm going to have x plus 0.075, x plus 20. Okay, so this will be 1.075 x plus 20. Okay, if I did t of f of x, then I would take x plus 0.057 x, and then I would plug this in for all of my x's, right? So I would have, and in this x, I would have x plus 20. So then I would multiply that out, and I would get 1.075 x plus, and if I go into my calculator, because I don't know this off the top of my head, 20 times 1.075, 21.5. Well, which one's going to be cheaper? That f of t, right? And what would that actually mean? That would mean to take your total purchase costs, right, which includes that sales tax. Like, you don't go to the store and just say, hey, I'm going to buy this stick of gum and I'm not going to pay the sales tax, right? Like, you don't have that option. You actually have to pay that percentage, right? Okay? And that's kind of true what would happen. Otherwise, you would take your original function, so you would take the amount of the stick of gum or the pack of gum plus the sales tax, and then you would add on that 20 for each piece of that. And we don't want that to happen. We like the fact that we're taking our total and adding 20 to it, right? Number 3, it says suppose taxes by law are not to be charged on delivery fees. Which composite function must then be used? Okay, so suppose taxes by law are not to be charged on delivery fees. Okay, so you can't take a tax on delivery fees. Okay, so you can't do T of F, right? Because then that would mean that you're taking 7.5% of that $20, which is not what we want to do. So for number 3, our best composite function for that would be this one, because we're not taking sales tax on that $20 delivery fee. That $20 delivery fee would be separate from the sales tax. Okay, these compositions are a little tricky. You have to make sure that you pay attention to the wording of it. It does come back later on in math, so you got to make sure that you're paying attention to it. Okay, so hopefully when you look at the independent practice, you get some practice on this stuff.